In a previous video, we had discussed random numbers and random number generation, and we introduced you to the concept that random number generation is truly random by showing you three different methods to generate random numbers. We had a die, we had some cards, and we had Legos. And each of those generated a different set of random numbers to illustrate the point of the difficulty of creating a mathematical equation to simulate random numbers. Because the problem with random numbers is there's an infinite number of possibilities on what a random number could be, because it is truly random. We also mentioned that if you want to start reducing variables and focus on one particular type of generator, that you would still see the same kind of phenomenon. That it's not, the difference wasn't that we use three different types of generators. It's because it's truly random. And entropy, which is measure of randomness, is existent in randomness, and the more entropy you have, the less order there is. And mathematics and computer programming and engineering and science is all about taking chaos and making order out of it, reducing entropy, making things predictable. However, some things aren't predictable, and that's why we try and use random number generators. Well, there's some drawbacks to random number generators in the fact that they have to be programmed. So we're taking empirical data and we're creating a mathematical algorithm, a mathematical model to simulate that data. But you're never going to get a perfect simulation because it's impossible to collect enough data to make it perfect, because there's always going to be more randomness. That's the whole idea of random number and randomness. So we have to make decisions on, is this random enough? And we have to be very, very cautious when we use computer-generated random numbers that we're actually generating truly random numbers, because somebody had to make the programs, so somebody had to put some kind of order to the chaos. And once you start putting order to the chaos, once you reduce entropy, you're reducing randomness. And so this becomes a real issue. And this is part of the conflict that you hear in science journals when interpreting data. For example, when interpreting data on climate change. You know, the data shows that there are changes in the climate. But what is unclear is how much of that is just the random variation of the climate, or if there's a trend, a pattern there, and if there are specific sources to that pattern. And that's a big part of the debate, is can you pinpoint it that well, because we know of the randomness of the universe, because of the existence of entropy. And entropy only doesn't exist when everything is in perfect order, and the one and only time that ever occurs is absolute zero. So since we're not at absolute zero and there's still energy, and atoms are energized, you will always have entropy. So it's a matter of how much of that randomness, that entropy, is the source of fluctuations and how much isn't. And that's the whole point of statistics and statistical analysis, is a good statistician never says, I'm 100% sure. They'll give levels of confidence. Say, this is at a 95% level of confidence. I'm 95% sure that I'm seeing a trend here. That there's something that we need to look at, that this isn't just random occurrences. And those levels of confidence will fluctuate. Sometimes you'll get down to what they call one standard deviation fluctuation, which is about like a 67% level of confidence. I'm 67% sure that what I'm seeing is not just a random coincidence, that there's actually a pattern there. So it depends on the level of confidence and how strong those statistics are. But it also depends on your equation, and you can get statistics to the point where you can mathematically pretty much eliminate a lot of the randomness by making an equation too precise, having too many different variables. And so you can see patterns and trends that don't necessarily exist, that are truly randomness. So we want to understand the concept of randomness. So because one of the arguments made against my first example on randomness is I use 3 different generators, we're going to take it to the next step. We're going to eliminate a variable. We're going to use the exact same generator, but we're going to do it 3 different times. So this is what I'm showing you here. This is, we're using the Legos, the colored Legos, the 6 different colors, pulled out of the bowl, blind. So you don't know what you're pulling. They're all the exact same size, so you can't use the size to bias your choice because they're all exactly the same. And we had 3 different people pull these colored Legos out of this bowl. So in the column to the left, you'll see a V. That's Victoria. That's Isaiah. And that's Michael. Now what I've done here is I've circled the first occurrence of a new color. So obviously, the first pick, you're going to have a new occurrence. So they're going to be circled. So let's look here at Victoria's picks, for example. So the second pick, she gets a different color. So right off the bat, she's 2 for 2. 2 different colors, 2 picks. And the third pick, same thing. 3 different colors, 3 different picks. And continues on to the fourth pick. So she's picked 4 times and has had no repeats. And that's a pretty significant randomness because that's not a very highly likely event. So I can feel confident with this that it truly is random because it's not very probable that you would have that. So we're seeing some kind of pattern here. Then she has a whole bunch of repeats until the 10th pick, and that's when she gets her 5th different color. So she went 4 for 4 on different colors. Then she had 5 in a row that were repeats. And look here, 3 of those repeats in a row were the exact same color. So now we're up to the 10th pick, and we're starting to look at this going, okay, if I were trying to like rig this, if I were trying to bias this, would this really make sense? You know, there's really no set pattern here. And then let's keep looking down. So we hit the 10th pick is when she gets the 5th different color. Now we have to go all the way down to the 23rd pick before she gets to the 6th color. So again, we've got a lot of duplicates, and there's really no consistency. We've got some whites, we've got some browns, we've got another white, and there's like no pattern. Nothing jumps out at you. And this is what you want to look at with your random numbers. If you're starting to see like trends or patterns, then your numbers probably aren't random because there's something involved. And so you want to make sure when you run random numbers that you're not seeing trends and patterns, because what you don't want is you don't want to assume something's random and it's actually not. So we get down, she gets to pick 23, and she finally gets the 6th color, and we did 27 picks. So then Isaiah picked, and his second pick was the exact same as first pick. So he has a duplicate right off the bat. And in the 3rd, 4th, and 5th, he's getting different picks. So he's 1 pick behind Victoria here. So he gets to his 4th pick on his 5th try, his 4th unique color. Now then he goes 2 more and he gets to the 5th unique color. So he's already had 5 unique colors out of 7 picks. So you're seeing there's really not a lot of consistency between the 2 of them. So you can feel pretty good. This is a pretty good random number generator. It's pretty random. And then you go down here and he had his 5th pick at 7. Well, it took him also to 23 to get his last pick. But remember, hers was at 10, so it took him a lot longer to get to 23. If there had been a pattern there, then you'd say, okay, if he's at 7, then you'd expect him to get that other pick somewhere around 19 or 20. and it'd be kind of like the same gap. If there was some kind of pattern, but there's not. And even his colors are completely random in how they did. See, like hers is like this, it skipped one, like you got white, 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 every other one. Then you had a brown, 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 every other one. Isaiah's was not. You had two, and then two of a different color, and then one, then two more, then two, and then here's these two here that are kind of separated out. So you're not seeing like this pattern here. Now let's look at Michael's. So he starts out, he's 2 for 2. Then he gets a duplicate. And then, so at the fourth pick, he's got 3. And then it takes him to 7 to get to 4. So Victoria got to 4 at 4. Isaiah got to 4 at 5. Michael didn't get to 4 until 7. So we're looking pretty good. This is we can feel pretty confident that our random number generator is really generating random numbers. Then he got to his 5th pick at 9. So he's ahead of Victoria, but behind Isaiah. And then looky here. He got to his 6th pick, the final one that was unique, at place 17. Well ahead of the other two. So you're kind of seeing here, again, there's no real pattern between all of these that jump out. So we want to do kind of an in-depth analysis here. So, for example, I broke it up into the 6 different colors: red, yellow, green, white, lime, brown. So reds, you can see Michael and Victoria both had 7. And there were 19 reds, 11 yellows, 18 greens, 9 whites, 9 limes, and 15 browns. So if there was a pattern, you'd probably see more consistency here, but there's not. And see, there's not even consistency among the 3. So, like, for example, Isaiah only had 1 white. Victoria only had 1 lime. Michael's here, his is a little more even. He's got, 2 5s, 2 3s, a 4, and a 7. But look at the variation here. We've got 8 greens, and then that 1 lonely little white. So that's good. That's showing randomness. So I broke it down again. How many 3s in a row did I have? 0 times. And 3s in a row is what I meant is that at the exact same spot, so let's say at spot number 8, that all 3 of them would pick the exact same color. And there is no occurrence out of the 27 picks that all 3 of them picked the exact same color at the same slot. We had 7 times that Victoria and Isaiah picked the same color, twice that Victoria and Michael picked the same color, 3 times that Isaiah and Michael picked the same color. So again, it's varied, so that's showing some randomness. Here I'm listing the first appearances of the different colors. The different colors appeared in different sequences. It appeared right off the bat for Victoria. For green, for example, was in slot 4 for Isaiah, slot 4 for Michael. Like this one here, white. 4 for Victoria was the 23rd pick for Isaiah and the 7th for Michael. So this is what really stands out in terms of randomness. 15 times at the same spot, at the same pick in the sequence, they each got different colors. So that pretty much tells you that we've got some randomness going on. And again, look at here. How long to the next color? So, we had 1, 2, 3, 4, 10, 23, 1, 3, 4, 5, 7, 23. And then, see, it's different here too. You got a 7, you got a 9, you got a 17. So picking Legos is a good random number generator. And it's a good way, if you have the time and the patience and you got a small sample, to generate random numbers.